Hello, good day everyone. This is Tefs. Welcome back to this channel. We have a Samsung 32-inch LED Smart TV, model U832F4000, which shows a standby light indicator but does not continue to turn on when the power button is pushed. I'll show you how to fix it. If you are interested in electronics and want to learn how to repair TVs and other electronic gadgets, you've come to the right channel. So be sure to like, subscribe, and ring the notification bell so you never miss a video like this. So let's get started. Not continue turning on could also be due to a voltage problem. Let's measure the voltages at the main power supply. We can measure the voltage at the cathode of the rectifier diodes. .8 volts were applied to this diode, 5.3 volts to that diode, 46.3 volts to another diode, and 115 volts to the last diode. Seems the voltages are steady and normal. But let's measure the voltage while pushing the power button. As you can see, the voltage drops when pushing the power button. It seems that the main power supply turns off when the TV attempts to turn on. Let's disconnect the LVDS cable that connects to the panel. The voltage still drops. Let's disconnect the backlight connection. The voltage still drops. It seems that the panel and backlight are not causing the power supply voltage to drop when the TV is turning on. Let's remove the main power supply to see more of the other side. When inspecting a power supply, ensure that the main capacitor is discharged for safety. The capacitor is charged only 9.8 volts, so it is safe for inspection. The power supply looks clean and have not been repaired before. While inspecting the circuit, I see some cold solder joints from the MOSFET and to the transformer. Let's resolder the cold solder joints and test if they are causing the voltage drop. Also solder the other that has a rivet through hole. Let's put the power board back in place and check if it solves the problem. The voltage still drops. The cold solder joints are not the cause of the problem. Let's inspect the motherboard to check for any shorted rail lines that could cause the voltage to drop. No shorted rail line has been found. Back to the power board. I analyzed the feedback circuit and I noticed that the cathode of the optocoupler line is going to another circuit that does not belong to the feedback circuit. This is the feedback circuit, and this is the optocoupler. The cathode of the optocoupler is going to the cathode of the TL431. But there's another connection going to this diode which does not belong to the feedback circuit, and goes to this transistor. I draw a simple circuit so it will be easy to understand. This is the feedback circuit. This is the feedback circuit on the PCB board. The cathode of the optocoupler goes to the anode of this diode, which is this diode on the PCB board, and to this transistor which is this transistor on the PCB board. As I said, this is the feedback circuit alone. Let's try to disconnect this diode which does not belong to the feedback circuit. The feedback should still work. Let's hang the diode on this pin too. The feedback circuit is part of the power supply that regulates the voltage to the desired level. If the feedback circuit fails, the result is no voltage or abnormal voltage. The diode is now disconnected. Let's place back the power board and see if it will work. My findings of the feedback circuit is if there is a voltage draw in the base of this transistor, the optocoupler raises the voltage to a high level, the main power supply trips off, and the TV will not turn on. Disconnecting this diode will leave alone the feedback circuit and hoping no more reason for the voltage drop. As you can see, the voltage now is going up to 13 volts. The voltage is 13 volts, which is indicated on the voltage outputs. No image because I forget to reconnect the LVDS cable. As you can see, the TV works fine even though the diode has been disconnected. Let's reconnect the diode and try to trace the problem. This transistor is connected to the circuit. As you can see, there are many components. I analyzed the circuit, and it seems that this line marks the end of all the components that define the circuit. So let's disconnect the jumper line and see if the TV will still work. The line is going to the circuit of the backlight driver. There is no problem with the LED backlight as you see it a while ago, so let's try to disconnect the line. The TV works fine even if the line going to the backlight circuit driver is disconnected. Samsung power board puts a complicated circuit to disable the operation when it detects an irregular problem like the backlight. But it seems the operation circuit disabler is the first that has an issue. If you encounter this issue, just disconnect this jumper.
A few moments later.
The TV now is working great. I'm sorry if I didn't explain all the circuit's operations. Some of them may need further explanation. To be honest, it is hard to explain all of them. By the way, thanks for watching. I hope you found this video enjoyable and educational. You can help this channel with your likes and descriptions. Ring the notification bell to keep you updated. Once again, I am Teps. See you again next time. Bye for now.